Hello there. This is Abel Gian, and here's another one of my projects that I did when I was in college. So this right here is my speed and battery design that I was working on for the electronics team for ASME. At the time, we were doing this competition called IGVC, which was basically just creating a autonomous land vehicle, more or less a robot. And basically, I was trying to design a way to basically find how much, I guess, voltage the actual robot itself had, and also the amount of like MPH, or I guess how fast the actual like robot was going itself. So basically, at the time, I think I was a sophomore. Yeah, pretty sure I was a sophomore. I think I did this like yeah, like 4 years ago, more or less. Yeah, 4 to 3. And essentially, I didn't really have that many electronics. I wasn't as like per se funded to get any good amount of electronics at the time. This was also during COVID too, if I can remember correctly. So we didn't really have that much access to the laboratory. So I did what I did uh, that I could was basically just use this program called Tinkercad. So if anybody's unaware of Tinkercad, again, a great website to use if anybody's interested in like doing some like basic circuitry slash coding for microcontrollers, specifically in Arduino. Essentially, it does like it has a well, Tinkercad's mostly famous for doing like this little like CADing little thing that anybody can do. While high schoolers use this, I know I used this when I was in high school, just for like some simple like 3D CADs. Um, but then later on, I believe in like 2019 or 2018, they also added a circuit side of it. So they basically had a little partnership with Arduino, or they had like some collaboration. I'm not really too sure about the specifics, but essentially you were able to create an actual like circuit within the website itself. So essentially, you can literally program a microcontroller, have the circuitry on it with like a breadboard, some resistors, like an LCD screen. In this case, you're gonna see like this little like I guess circle shape thing, which basically represents a motor slash encoder. And also this right here basically just controls the voltage and how much juice you're actually giving the whole thing. So essentially you're able to do this. You're able to like upload some code, which is like right here. This took a bit of time, a lot of research. Again, using the Arduino manual and also some sources from online to basically make this all possible. So essentially, what this is supposed to do is basically just show how much juice it has. It doesn't need to be specific too. Basically, what I kind of did was like did this little like battery icon thing, which is honestly, I was really happy about this. I was like, oh my god, it actually worked. Um, and also like shows like at least like the MPH of this thing. At least for in this case, this was programmed for a specific type of wheel. And let me see if I can remember the size of it. It's been a while. Again, it's like 4 years. Let me see. Essentially, there was like some math right here. Let me see. Ooh, man, this is gonna be a while. Yep, this is gonna be real fun. But basically, the wheel was basically just the one that we had for the actual like robot itself. So it was custom made for that in that regard. And basically for Arduino, I mean for the Tinkercad side of things, essentially they have this cool little module where you basically like can program like a motor, but it also has an encoder on it too. So just like a quick like summary of what an encoder is, if anybody's unfamiliar, an encoder basically just detects how many revolutions, let's just say like a thing is like a spinning thing is making per se. It can do an actual RPM of it. This is useful for like motors, for calculating how much RPM a like disk drive is like outputting or all that stuff. And essentially, yeah, that's pretty much it. So basically, how to do this little Tinkercad simulation thing is basically you have the thing, you have your setup, you have your code uploaded, all that stuff, and basically what you do is just click on this part right here, start simulation, and basically, boom, hey, you basically have this right here. And just starting it off, not really touching anything. You saw that like I'm trying to remember how I programmed it. Let me see if I can just look at the code. Yeah, it usually tells me a little bit better. Ah, there we go. So basically, anything that's like 10 volts or higher is gonna show like like a full like battery right here, as you can see right here through the LCD screen. Let me see if I can, yeah, through the actual LCD screen. And essentially, it also shows you the speed. So again, based on like the actual like dimensions of the actual wheel, um, doing some quick little conversion math, 271 RPM will equivalent to about 2.49 miles per hour of speed. Again, not showing like actual like it's not it's not showing the actual direction, but just the magnitude itself. And basically, just by controlling the juice right here, if I basically just let me just show you. This right here is like 10.4, so if I just try to do to like 9.3, you see, like, look at this, the battery actually like shows that it decrease, at least for like voltage wise. So let me see if I do this. Yeah, it decreases, decreases, decreases until you kind of see that I can go to the very bottom. And also, in this setup too, again for testing purposes, I basically just I did this like pretty simple. I didn't like do like a little like motor controller or anything, but basically the amount of like output that this little thing like the amount of like RPM it gives out is just based on like how much juice you're giving it, how much voltage it has. Because let me see, I'm trying to remember. So yeah, these two were just pretty much just just controlling the actual motor. And oh man, it's been a good while. But I'm pretty sure this one here, channel B, and the light blue one, channel A, were just the actual encoder itself. And then oh yeah, and then this one right here, yeah, just shows the actual encoder juice itself. So again, maybe I could have done it a separate way where like, the power itself was not dependent on like how much speed it's going, yada yada yada. But it was just for fun, just doing this into like one quick setup. I don't even know if this was actually the final product that my org did. I kind of left a little early, but I gave it to them. I hope they used it. I'm trying to remember. I'm pretty sure we did test out the encoder though at that time, an actual like physical encoder. I remember the code like overall changed, but this part of the then this design, this was like the final version that I created, which I was just overall happy with. I enjoyed. But yeah, that's pretty much it. Let me see. So yeah, again, like if I go like a little higher with like more speed, more juice, you can kind of see that the speed's going to increase in a quick second. Yep, 4.22 miles per hour. Let me see if I can try to do the max. Ooh, and then I think for this, I guess, type of motor, or yeah, this type of motor, like if you just go like over like, yeah, 25 volts, it just blows up. So definitely try not to do 25 volts. I don't think anybody would try to do 25 volts on this little, I don't know, looks like an RC motor kind of. So yeah, and then I believe there was like one little thing, a little side effect, but I remember I tested it, at least the speed stuff, um, and like in the physical medium. I said like I don't have any video of that, but basically, I believe it's like a Tinkercad glitch. But basically, when this thing goes at a zero voltage, basically, yeah, the battery works, but then you're gonna see the speed. Now, obviously, just doing like common sense, it's just gonna become zero. Okay, so if I try to like increase it, yeah, let me see. Yeah, it becomes zero, and I don't think it was lag right there. Maybe okay, okay. I think like the part where like it turned to like 0 mph was lag, but definitely when you try to like change the voltage right here, it increased. And I remember I had a team member who was also working on like a certain part of this code too, with his own like design. Also had the same situation too, at least on Tinkercad. Um, so I'm pretty sure it was a Tinkercad issue because I remember we did test it out and it did work. But the battery definitely worked, so that was definitely it. And yeah, it was all possible to do it on one LCD screen. And again, I'm really just happy with like how just like the little icon, the battery icon. That took a bit of time to learn. That one was again like, let me see if I can show up the code. Mostly just yeah, just doing this little things right here. Where basically it kind of shows like what you want to like actually like include to the actual code. So like yeah, I think like I like labeled it to like full top battery, full middle battery, full end battery, or like full metal, which is like this little part right here, just shows how much it has. So like let me see how many like actual like dots there are in like each row. So there'd be like yeah, let me see. Well, I mean, there's actually in total. You could just look at this right here, just ignoring like the B's and all that stuff, just starting from like the first I guess number. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 rows, and in total, 1, 2, 3, 4, 5 columns. So that's basically how you kind of like do that pixelation, at least in this part, and just like label it as like a byte, and you basically just upload it to this part of the code. And yeah, that's mostly it. That's mostly what I wanted to showcase. Again, took a bit of time, a lot of research. just basically doing this. It was like one of the main issues was basically just having this thing not blow up the actual Arduino or LCD screen, which is where the this little part right here kind of has its miracles. Again, this thing is a lifesaver, not just in this project but in many other projects, which is a MOSFET. Yeah. So yeah, that's definitely it. I hope you guys enjoyed that little part of the video, and yeah, that's pretty much my project. Bye.